So step one, what we're going to do is we're going to create Tn plus 1, and Tn using linear solution. Okay, so we have an plus b, and then we're going to have a times n plus 1 times b, and then we're going to have a times n plus 2 times b. And I'm just going to sub these in. All right, so what we have here is our green one. This is our green one. I'm going to multiply them. So it's going to be an plus 2a plus b. That's the green one done. Then I'm going to go for the blue one, which is now this one here. And I'm going to get an plus a plus b. Then I'm going to have 4 times my red one, which is 4 times an. Well, one sec. Oh yes, thank you. The middle one is actually the blue one. I actually left out the minus 4, didn't I? So I'm going to multiply all of the blue part by minus 4. So it's actually minus 4an minus 4a minus 4b. Thanks for spotting that. And I'm just going to slot it in back up there now. So we all forgot about the minus 4 there. I already did anyway. Fixed. Okay, thanks. And then times the b part is 4b, is it? Okay, so we have all of that. I'm just going to drag it down here. Now, what we're saying that equals 7n minus 14. Okay, so let's roll with this. How many ANs am I looking at here? I think I'm just looking at one, am I? Anybody verifying that? Yeah, so I have AN on the left, yeah. Now, how many A's do I have? 2A minus 4A. Oh, that's it, isn't it? Plus 2n minus 4a, which is minus 2a. And then b minus 4b plus 4b. Is everybody happy just with minus b there? I say plus b? Plus b? Give me a look. 4b and 4b. Who's happy with b? Okay, that's all right. Now, and then we have 7n minus 14, don't we? Now we can clearly see that the a is what? 7. And if that's the case, then we can say that this part here equals 14. So it's minus 2 times 4 plus b is minus 14. And we can clearly see that b is 0, isn't it? So we're happy that b is 0? Okay. Therefore, what's our particular solution? The particular solution is, what do you say? Tn equals 7 to the power of, oh sorry, 7n, not 7 power n, 7n. All good so far? Tough, they're tough. Now, what we're going to do next is, once I'm done with this identity, I'm going to move on to part 2. And part 2 is to find the complementary solution, so the comp. And what I'm doing is I'm striking off the right-hand side to be 0, and I'm engaging a second order homogeneous equation, which is x squared minus 4x plus 4. Everybody got that? The rule is for part 2, you always put equal to 0. And then Tn plus 2 is the x squared, Tn plus 1 is the x, and Tn is the x. Oh, sorry, Tn is just cancels. Huh? Tn equals 7n. Do you remember we got a equals 7? A equals 7 and b equals 0. And this is for the particular solution. So the particular solution doesn't affect the complementary solution. You can get one wrong and the other one, Right, yeah. Now, what we're noticing about the part two, the complementary solution is it's a repeated root. When you solve that, you're going to get x equals 2 twice. Then you're going to have to use the homogeneous rule 2, which is this one here, which is going to be Tn equals, what's it, L to the power of n, and then Mn, so it's going to be m times n 2 to the power of n. Okay, and that is known as our complementary solution. Cool. Okay, now part three, not part three, yeah. Oh, part three, total solution. So what's our total solution again? It's our complementary plus our particular. They're long, aren't they? Anybody get that far? Okay, what are we going to drag down now? T0 equals 1 and T1 equals 15. Okay, we're going to put them in, aren't we? What do we get? L times to the power 0 plus n times 0 to the power 0 plus 7n. So what do we think of 7n is? 7 times. And the whole thing equals 1. All right, this is leading us to L equals 1, is it? Are you happy with that? This comes out as L equals 1. Now I have Tn equals 1. So let's change that L on top to 1. It's in your head, yeah? And then we're going for T1 now. So what's T1? 15. So it's going to be 2 to the power 1 plus m times 1 to the power 1 plus 7n. So 7 times 1. And that equals 15. What can we say then? 2 plus 2m plus 7 equals 15. 2m equals 6. M equals 3. Yeah, we got it. And then compose it all into one big solution. I'm looking at here. I'm looking, oh, sorry, not looking at there. I'm looking at the one above it. Okay, so it's going to be to the power of n. It's going to be mn, so it's going to be 3 times n to the power of n plus 7 n. And we're done. Okay. This one here is basically verify that this here is a solution of this. So we already know what un is. Now, all I want to do next is find out what un plus 1 is. And un plus 1 is 6n plus 1 plus 2, n plus 1 plus n. It's a bit like induction. The two of them are incompatible with each other as it currently stands. So what we're going to do is we're going to change it as to 6 by power n, and that's going to be 2 times power n, and that's going to be plus n. And while I'm at it, it is plus n plus 1. Thank you. Well done. Because you have to replace n with n plus 1. Now we're going to multiply this whole system by minus 8. Is that okay? Just while we're here. So it's going to be minus 48, 6 to the power of n. What do we take? Minus 16 to the power of n, and then minus 8n minus 8. It's going to store that there. Is that okay? Now we're going to do un plus 2. So what's un plus 2, do we reckon? 6 to the power of n plus 2 to the power of n plus 2 plus n plus 2. Now, 6n plus 2, what do we think that is? 6 squared 6n, which is, anybody? 36, 6 power of n. And 2n plus 2 is 2 squared by 2 to the power of n, which is 4 times 2 to the power of n. And then on the other side, it's just your n plus 2, isn't it? Now what do we want to do with this answer? We want to multiply that by, wait, oh, just 1. You're saving me today. So you ready? Here we go. Now, we're going to start off with un plus 2. So I'm just going to drag this up slightly. And let's get myself a bit more board space. Okay, I'm going to drag this up. Oh, I see what I did there. Never mind. Oh, it doesn't work. All right, let's do this again. Huh? Yeah, that's what I should have done. That also gets rid of the question, though. All right, so that's your un plus 1, isn't it? So that's your un plus 2. This is your minus. This is your minus 8 n plus 1, yeah? This whole thing is going to need to be grouped and shrunk. Okay, there we go. Okay, the 12 un. Haven't done that yet, have I? So 12 un is going to be plus 12 6 to the power of n, yeah? And then plus 12 to the power of n. And then plus 6n, or sorry, plus 12n. And the whole thing. Now we're just going to add all these together. Okay, let's see what happens to the 6 to the power of n's. 36 of them, 48 of them, plus 12 of them. What do we think? 0, 6 to the n's, which is nothing, right? Now, what are we going to think about the 2 to the power of n's? 4 of them, minus 16 of them, plus 12 of them. 0, 2 to the power of n's, gone. How many n's? 1, minus 7. Is that right? Oh yeah, it's going to be 13 take away 8, which is 5. And the numbers at the end, 2 take away 8 is minus 6. Yeah. And therefore, we've proven it. QED, which means I gave you exactly what you're looking for. Is that right? Quadrat demonstratum in Latin. My teacher